2.2 applications of systems of equations. Of course, it just says applications on Canvas, but applications. Really, when you see the word applications like this, it just means word problems. And since we love word problems, this isn't too bad. I do want to say that the other one's based on price, but it's just based on whatever other quantity is provided. But again, we're looking at two variables on that. I generally use X and Y, but we don't have to use X and Y. You can use whatever two variables you choose, okay? So just be aware, we do need to pay attention to the quantities. This may take some reading and rereading on these. Now, the other good news, by the way, is we get so caught up in the equation thing that sometimes I think we forget that we can just solve these without the equation. And I'm talking about like guess and test. So especially when it comes to prices and stuff, some students prefer to use guess and test. It may take longer, but it's more efficient for them, actually. Are you ever going to be forced to use one way or the other? Not as far as I know. So maybe on the final, but we'll see.
They wouldn't force us to use guess and test.
Oh, no. So guess and test is the non-formal math way to do it, but it is a problem-solving strategy that is legitimate. And then, yeah, analyzing the information may be helpful too. I like to look at the equations and see, like we saw last time, I like to look at the equations and kind of determine which method for solving the system would be best, but maybe one isn't always so obvious. So let's read. So again, reading is one of the key things that people miss. And when I say people, I'm talking about me. Okay, so I tend to just skip over the wording and then just solve. And then I end up solving for the wrong thing, or I just solve it wrong because I didn't really read through it. So let's read through it. A store owner want, that's Mr. Sells typing right there. A store owner want to develop a new snack mix by mixing chocolate and trail mix. How many pounds of chocolate costing $9.10 per pound should be mixed with 20 pounds of trail mix costing $3.80 per pound to create a mixture worth $5.68 per pound, round to the nearest pound? Okay, so I've got two things going into this trail mix, okay, and I want to identify those right off the bat. Is looks like we're putting in some chocolate, right? Chocolate, and then we're going to put in some trail mix to create some kind of mixture, like a chocolate trail mix. I don't know. But in any case, we got some chocolate going on, right? So let's put that down here. And then we got some, I guess I kind of covered that up. Hopefully that's okay. Trail mix. Now, we got two equations to write on the chocolate and the trail mix, okay? And the first thing that I noticed here is that we have a price for the chocolate, a price for the trail mix, and then a price for the mix, okay? So let's create an equation just based off of the price. Yeah, I guess you could say cost if you wanted to, but it doesn't matter. So chocolate, excuse me. I'm gonna use, I want to use X so bad right here, but most students say that they'd prefer I use C. I'm talking about past classes. They want me to use the variable C for chocolate, okay? All right, no problem. Now, how do we find the price of the chocolate? Just the chocolate part of the mix. Well, we know it's $9.10, at least that's what the problem said. That's for every pound of chocolate that's used. So I would multiply that by C, which I'll define as pounds. Pounds of chocolate. Some kind of chocolate. So C is pounds of chocolate, okay? So $9.10 times the number of pounds of chocolate, that would tell me the price of just the chocolate part of it. But then we have the trail mix, which, again, I want to use Y, but we'll use T. That will be pounds of trail mix. All right, so if I wanted the price for the trail mix, oh, it says that we got $3.80 for every pound of trail mix, but it also says we're using up, oh, I apologize, I do not need T on here for my trail mix. Fair enough.
What are you gonna use? Are you gonna use?
So, yeah, we don't need the T for the trail mix because we know how many pounds of trail mix. This is why it's important to read and reread the problem right here, which I probably should have done the second time. 20 pounds of trail mix, we already know is 20 pounds of trail mix. So the other variable, right? Well, what is the other variable for? We're looking at the final mixture. I'm gonna put final mix. Now the final mix, the pounds of final mix, I don't know, I guess I probably shouldn't use F, but that's okay. F is the pounds of the final mix, okay? All right, now do we know how many pounds that is? No, that's why I have to use a variable for it. But it says here, yeah, 568 for every pound. So the final trail mix should be $5.68 for every pound. We just don't know how many pounds it is. So, but I did say that we'll use F. I don't want to use lowercase f, then it looks like a function. So maybe F isn't a very good letter to use, but it doesn't matter, right? Because we're creating this ourselves. So if you took the cost or the price for the chocolate and then added that to the price of the trail mix, you should get the overall price of the final mix. Right here, there's, boom, that's one equation right there. And I can tell by everyone's faces how much fun that was. Okay, now we gotta create an equation. What was the other quantity that was given to us? It's pounds. We got pounds of mix, pounds of trail mix, and then pounds of chocolate, right? So we got the next equation is based off of the pounds. Okay, so how many pounds of chocolate were there? C, that's all we had. And then the trail mix, yeah, 20 pounds. And then we had pounds of the final mix, which I would consider that the total, but we don't know how many pounds that is. It's some kind of F number right there. So if you take the C, pounds of chocolate plus the 20 pounds of trail mix, you would have the final mix pounds right there. So I took quite a bit to set that up, because usually this is the hardest part that most students struggle with. If they can get this system down, it's like, oh, I can solve it now, but you just got to get to this point, right? So yeah, this are we going to use substitution? Now, if I were to look at this, let's see, right, this is F equals something. So the answer is you could. Okay, well, what other method could you use? Well, the only one we have used in this class is elimination, which you could use as well. Doesn't matter. Since this is set up as F equals something, yeah, I probably would go into substitution right here. So here's what we mean by that. Let's take that first equation based on the prices. So there's that first equation based on price. I just copied it down exactly, but now I'm going to substitute the F letter or variable with what F represents, which is the cost plus the 20. And this now is an equation with one variable. Hey, that's not too bad, right? Like we can solve that. We do have some distribution here, so I should get my calculator out. Let's go back because I skipped that part, right? It's not just 20, yeah, so,
You don't need a raise.
well,
No, you do.
yeah, well, there's one at the store I can let you get, you know. It's available anytime, by the way. So I forgot to do this multiplication. Let's do it now before I forget, because I already forgot once.
7,600?
By the way, you guys told me it's 76. I believe you. It's just, as a math nerd, it always makes me nervous. Oh, I apologize. This, by the way, was 20, but I'm still making mistakes here. But just the math nerd in me is like, is it really 76? I trust you guys. Okay, so that's 76. Not, I had the 20 over there, right? Yeah. What the heck did I do? So 76 right there. Okay, now we're ready to do some multiplication. And before I ask, because then it's just the math nerd in me, I do apologize. I've now done, so that no one can tell me, 5.6. I know 5.68 times C is just 5.68C.
Do you do that in your head?
Well, that part, yeah. It was, yeah, right. I should get like a treat or something. But I did 5.68 times 20 as well, so 113.6. And then the rest of that, or the left side of that equation stays the same.
Can you multiply that by 100?
Yes, you can multiply both sides by 100 to get rid of the decimals. I'm keeping the decimals because I'm doing all the calculations on this sucker right here, the calculator. And it will do it for me, but also happily. So now I'm going to use principle of equality. I'm going to do two principles of equality in one. I'm going to place my C's on the left side and the numbers on the right. If you've never seen this before, let me explain briefly though. So I want all my C terms on the left and then all my constants, just the regular numbers, on the right side, which means that plus 76 there in purple, it's on the incorrect side. I'm going to have to zero that out. But it is a principle of equality, so if I do it to one side, I need to do it to the other side. Now, I'm not worried about the calculation because we'll get there. But then we also have 5.68C in orange on the right. It has to be zeroed out as well because it's on the number side of things. So I'm going to have to subtract 5.68C from the right side and the left side just to maintain my principles of equality. So that'll tell me how many C's I get on the left. Let's see what that is. So 9.1 minus 5.68, enter, and I get 3.42 C's on the left. So the 76 minus 76, yeah, that zeroes out. 5.68C minus 5.68C zeroes out just as we planned, okay? So that's principles of equality. We could have literally subtracted or added to anything as many as we wanted to, but we're doing that with purpose to force zeros to happen. Then I can take the 113.6 minus 76 as well, which now shows 37.6. Now we only want one C, right? So we're going to divide now both sides by 3.42. So what this does is it makes that 1C, which is really what we want. I'm just going to show it a C, by the way. And then 37.6 divided by 3.42, enter, and I get 10.9. Here's what I get, 10.994. I'm going to stop there. Now, and that was pounds of chocolate, right? So that's pounds of chocolate. Yeah, they do want us to round to the nearest pound. And when it comes to chocolate, I would just prefer to just round up, but it's going to be the same thing. That's going to be 11 pounds right there. Okay, now that's just pounds of chocolate, right? Oh, crap. I guess I should label it pounds of chocolate, even though I have it color-coded.
Minus 1 point.
No, I remembered, so I'm good. So, but we do have the pounds of trail mix as well. We want the final mix because it did say, where is it? How many pounds of chocolate costing this? Pound of the mixture. Oh, I guess it did just want the chocolate, but we could find the final mix, right? Because we can go to that second equation that's based on pounds. We now have chocolate at 11 pounds, and then we could have just said, well, 11 plus 20, boom. That would have been 31 pounds of total mix. I guess they didn't really ask for that though. So to solve this one, I'm going to choose to eliminate the y's, specifically because making this coefficient a 4 is going to be a lot easier than making this one a 1.5. Now, not only do I need that coefficient of y to be a 4, I need it to be a negative 4. So I'm going to have to multiply all the values by negative 4. So negative 4 times x would be negative 4x's. Negative 4 times positive y would be negative 4y's. And then using my calculator, I've got negative 4 times 271. Enter, and I get that equals negative 1,084. Okay, so it's going to equal the equation there at the top. That's just 1.50x plus the 4y, and this equals 694. And we can see just the way this sets up, right, because we have the x's, y's, and constants all lined up. The y's are opposite coefficients, so that means they will actually zero out. So in solving this, I'm just going to add all the columns together. So 1.50x's minus 4x's would be negative 2.5x's. In fact, we make it 2.50x's. The 4y minus 4y, that zeroes out, just as we planned, that eliminated. And then we have 694 minus 1,084, which is negative 390. And again, I'm just using a calculator for that. Now that I have this equation, this new equation in red, I can solve for x pretty easily just by dividing both sides by negative 2.50. Yes, it is a principle of equality, so if you do it to one side, you must do it to the other side as well. And when I do that, I get 156 as my x value. I know, based on what we see up here, x is the number of children, so that right there would be 156 children as the actual answer. So I'll just circle that in there. Okay, now if I want to figure out how many adults, I take the total number of people that entered the park, which is 271, and then I simply subtract the number of children that were entered the park, because we now know that value, which is 156. When I subtract these, I should get the number of adults. So let's see, 271 minus 156, and I get 115. That would be 115 adults. Okay, and that should work. So, but let's go ahead and check. Okay, so 115 plus 156, enter, and we do get 271 people. This equation checks off. If I replace x with 156, y with 115, I get a true statement. Okay, well, what about this one? So I'm going to replace the x with 156, y with 115. Let's see. So 1.50 times x, which is 156, plus 4 times the y, which is 115. Enter, and I get 694. So that just clarifies and confirms that we have, in fact, solved these correctly. We have 115 adults, 156 children. Don't forget to label your answers on these word type problems as well. You need to mix a 20% acid solution with a 60% acid solution. And of course, I put this in here because most students hate the acid ones, because usually it's actually is because of the percentage. Hopefully we'll see that it's not too bad. To create 200 milliliters of a 30% solution, how many milliliters of each solution must you use? All right, so we have the two parts, right? We got the 20% acid solution, then we got the 60% acid right there. So that's part of the mix, right? So I'm going to say I've got just to make the equations, we got the 20% acid, and then we got the 60% acid. Let's make that pretty. There we go. Okay. And then we have, I guess we have the solution as well, the final solution, which is the 30% solution. There we go. So we need to acknowledge that when we combine those two, then we should end up with a 30% solution. So, I mean, you could show if you added those together, you need some kind of 30% solution. Now, this is not the equation. This is how the equations are going to set up, though. Okay, so please don't get those confused. So we got 20% solution. You know what? I'm going to say that X is, I guess, milliliters of the 20% acid. And then the other value, the 60% solution, again, we don't know how much that is, so I'm going to use Y on this one. But again, that's milliliters of 60% acid. All right, so our first equation is going to be, I'm going to base this off of, I feel like I should do it on milliliters, but I'm going to do it on the percents, okay?
Wait, what?
I'm saying percent because I don't know the scientific term for what it is. Maybe it's the solution, percent solution. And I feel if I put that on there, I feel better in my heart, but I don't know if that helps you guys out. Percent, the first equation is just gonna be based off the percent solution, okay? So, how do you find the percent of the solution? And I guess it's kind of like, again, I'm trying to think of the word, and it just never works in my head. Maybe it's because I'm a math nerd, but if we take the amount of the 20% acid and just multiply it by 20% right here, that tells us kind of the final solution, just based off of how much we have. It's 20% solution and how much we have, so it's 20% solution. So yeah, what you're saying is if you wanted to use 20 right here, I do believe it works so long as you use, as all the percentages are written as whole values. Well, like I said, I'm using 0.2 because that's the decimal form of 20%. So yeah, is this the only way to do it? Of course not. And if you have your own way, yeah, feel free to do that. Do it that way, okay? So the 60% acid, we got to multiply it by how much acid that is, it's Y. And then it's concentration, I guess, 60%. But like I said, I'm going to write it as 0.60. So that's the 60% acid. And then we have the final solution, which is 30%, so that'd be 0.30.
You gotta stop saying final solution. You sound like a Nazi.
Oh, boy. Okay,
It'll
so,
make you better.
thank you.
I'm talking about the Jewish problem.
So there's 200 milliliters of that 30% solution. We just don't know how much of it is 20% acid and 60% acid, but we do know how much of the final solution we want. So we see that this equation sets up this way. Of course, if you were adding the two acids together, the 20% and 60%, we want the final solution to be at 30%, 200 milliliters at 30%. Now, for those of you science nerds that are like, I already know what that is, you know, with the percent times the amount, mathematically, we would say it's a percent milliliters, but again, that just doesn't make sense in my head. All right, and the next equation is based off of the milliliters. So the 20% acid, there's X milliliters, and the 60% acid is Y milliliters. If we were to add those together, we should get the final mix, which is 200 milliliters. And that is our system of equation. All right, so this top equation, 0.30 times 200. So I'm actually gonna see what that is. 0.3 times 200, I think it's 60, there it is. Okay, so what I'm gonna do is I'm gonna set this aside just so we know where it came from. And in fact, I'll just kind of set it there. And then, but I now know that when I multiplied those two, that I got 60, right? So let's get rid of this and let's replace it with the value that we get from the multiplication. Really, that's for me, just so I don't forget, but not everyone needs that right there. So now I have a value of 60 right there, okay? So this now, these two equations are able to be solved, right? And I'm looking at coefficients of x and y's, doesn't really matter. I just need to eliminate one of them. I'll choose the x's just because it's a smaller number, and really that's the only reason why I'm doing it. But do you have to eliminate the x's? No, you can eliminate the y's. So I'm going to take the bottom equation. The top equation, it can stay how it is. Okay, so that'd be 0.20x plus 0.60y, which equals 60. Okay, so that's the top equation. But we have the bottom equation. Let's go ahead and take it. And we're going to multiply the whole thing by 0.20. In fact, I'm going to make it a negative so that the coefficients will automatically be opposites. So here's what we get. Negative 0.20 times x would be negative 0.20x. And again, these are opposites. The coefficients are opposites right now, so I know they will eliminate, but also times the y. So that'd be negative 0.20y, which would equal 200 times 0.2 negative, which is negative 40. So from these two equations that we have, if I add them together, which I will do, and add all of the columns together, that will eliminate these x's. Okay, so I got 0.60 0.60Ys plus negative 0.20Ys, which is 0.40Ys, which equals 60 plus negative 40 is 20. And then last of all here, just to solve that last part of the equation there, I just want this to be y equals, so I'm going to divide both sides by 0.40. So 20 divided by 0.40. My calculator gave me 50. Now again, what does y represent? Y is the milliliters of acid right there. So I'm just going to label that 50 milliliters. And that was of the 60% acid. I'll just be a little more specific on this one. 50 milliliters of 60% acid. Now that I know how many milliliters of 60% acid, and we also know that the total mix will be 200 milliliters, I just need to subtract those 50 milliliters, and that will tell me how many milliliters of the X, that's the 20% acid. 200 minus 50 is 150. Again, that's milliliters, but that's of the 20% acid. So let's just check. Okay, so 150 plus the 50, that's 200. That was easy math. But how about 0.2 times the X, that was 150, plus 0.6 times the Y, which was 50. If I push enter, I get 60. And remember, we already multiplied the 30% times 200, so that's a 60 right there. It checks off. Both of those give us a true statement. And now I know that we have found the solutions. We got some more. This one actually isn't too bad. It sounds worse than it is, I guess. So if you wanted to mix pure methane with water and end up with 80 gallons of 45% methane, how many gallons of each should you use? See, and this is where my math nerdiness comes into play. I thought methane was a gas, but it's making it sound like we're mixing two liquids. So if I'm wrong, don't correct me because I want to feel good about myself. Actually, I wouldn't care.
I thought methane was a gas.
I wouldn't care, but so apparently this is a pure methane is a liquid. But I feel like I'm already getting into science nerdiness, and that's a whole different type of nerd. We don't like those types of nerds. We don't care, of course, but I have to say that as a math person. Okay, so we want two equations, right? And the two things we got right here is we got the methane and we got the water.
Correct, it is a gas.
Yes, except I am able to express gallons of water in methane. Because water, as it turns out, is, again, this is my limited knowledge, it's 0% methane. Now I want to do the equation this way because it makes me feel better. Does that mean you can't, does that mean you have to do it this way? No. Okay, so here's my equation. Just for the methane, it's 100%, so I'm going to show that as 1.00 times the amount of pure methane that we're putting into this mix. Okay, the water, on the other hand, is 0% methane, and since I'm comparing it with methane, I need to multiply it by M. Now, that may seem weird, but it's going to do something magical for us. And by magical, I mean math nerdy. So the 45% methane, though, of course, that's a 0.45. And it did tell us as well that it wants that to be 80 gallons. So I'm going to have to multiply that by 80. So let's rewrite this equation. But all I mean by that is I'm going to take the 0.45 and times 80. So 0.45 times 80, enter, and that would be 36. Okay, so the new equation, I'm going to rewrite it this way. Okay. In fact, from here though, let's figure out, because that's based off of the percentage of methanol. Okay, so we know that that equation is the percentage of methanol. So I'm going to label that equation in percentage. But we can also find the equation based off of, what is it, the gallons of methanol. There we go. So, how many gallons of methanol? Well, you got methanol, and you could even say add that to the amount of water that you have, and that would give you the mix, which would be 80 gallons. Which may be something to keep in mind. I know this top equation right here is written in just in methanol. That's okay, right? Because water is just 0% methanol. But we need this equation, not necessarily, but mathematically we can say that we need it. Here's what I mean, is when I solve for the methanol, which I will do up here, I could just take the mixture volume, 80 gallons, and just subtract whatever I find for the methanol. So what is the methanol? Well, as it turns out, this part of the expression, 0.00 m, that's just zero right there. I can actually zero that out, and what I end up with is this equation. 1.00 m equals the 36. Okay, what this tells us is that's all the methanol there is. The methanol, 100% pure methanol, that's 36, and that was gallons of methanol. Okay, so that's, I'll put gallons right there. In fact, I'll say of methanol. So 36 gallons of methanol, but we know that the total mix is 80. So if I want the amount of water, I can just take the 80 gallons total, subtract the 36 gallons of methanol, that's a 6 by the way, and I end up with 44. Okay, so that's the amount of water that I have. Let's go and label that. That's gallons of water. So that's both the values that we needed. We now know that there are 36 gallons of methanol, and then down here in the bottom right, there are 44 gallons of water. Now again, you can check 1 times 36 plus 0 times 44, really 0 times anything equals the 36. And then down here, the methanol plus the water, 36 plus 44, boom, 80. So it checks out both ways, and we have our answer there. You want to know what your average paddling rate was for a canoe trip to a campsite. On the way there, it took you 9 hours against a river current of 2 kilometers per hour. On the way back, the same distance took you 5 hours with the same distance of, with the same 2 kilometer per hour current. Let R equal your average paddling rate. Express the rates against the current and with the current in terms of R to complete the table below. Using the information summarized in the above table, set up an equation to solve for your average paddling rate R. No problem. But first, what we want to address here is that when solving for distance, rate, and time, we need to remember that distance does equal the rate times the time. Okay, that's going to be important for us as we start figuring these out. So let's start first with the against the current. Okay, so here's something else that we know about these two. Whether you're going against the current or with the current, the distance is the same. They didn't say that the distance was ever different on this. It's the same trip, just one is with the river current, the other is against the river current. So when we want the rate for, let's say it's against the current, What we know about the current also is that it's running at 2 kilometers per hour, whether you're going with it or against it, okay? Now, with it or against, it's going to change the rate for us, and here's how. If you're going against the current, you have the rate that you're paddling at. So I'm using R, that's the value they told us to use. Again, this is against the current, so it's slowing you down. To show that it's slowing you down by 2 kilometers per hour, we're going to put subtraction between the R and the 2. It's your rate of paddling, but then take away 2 kilometers from the current. So if we were going with the current, you'd have your rate of paddling, but now that 2 needs to be added to your paddling rate because it's going to make you faster. These rates that we're talking about here, this is all speed, right? So the current can take away from your speed, that's why it's subtraction. Or if you go with the current, it will add to your speed. Now, something else we notice here is that if you're going against the current, that trip took you 9 hours. The reason why we need that is that's the time. So the time going against the current was 9 hours. Going with the current was 5 hours, so that's time as well, but that's with the current, and yeah, we did expect that to take less time. So this is how you're going to fill in those boxes. But now we need to fill in some kind of equation, right? Now the basis for our equation is you have the distance, which is the same whether you're going against the current or with the current. All right. So we know the distance. Now, instead of writing it as d, we're going to substitute it as rate times the time. But we know both of those values. Let's start with the rate. Okay, so instead of the rate, I have that expression for the rate, which is my rate of paddling, or yours, and it's against the current, so that's -2. And then we also know that the time it took was 9 hours. So I've got to multiply that by 9. And this should equal then the distance with the current, which again, it should just be rate times time. Well, we know both those values, kind of. The rate is an expression, and that's okay. Right, we know the rate is our rate of paddling, but then we have to add 2 kilometers per hour for the current. And then we know that the time that it took for the trip, so the t I'm replacing with 5. Okay, so this is the equation. I think this is the equation that they want. Now that I have it, I'm able to solve. I'll distribute the 9 into the parentheses. That'd be 9r minus 18. And then this would equal, distributing the 5 here, that'd be 5r plus 10. Okay, so I can use the principle of equality here to start solving this. So remember, whatever I do to one side, I got to the other side. I'm going to keep my r's on the left and then the numbers on the right. So the negative 18, I'll have to zero out by adding 18. But if I do it to one side, I got to do the other side. And then the 5r as well. I'm going to have to zero that out because it's on the number side of things. So I'll subtract 5r from both sides. So what happens here? The 9r minus the 5r's is 4r's. The 18's 0 out. This would equal 5r zeros out. 10 plus 18 is 28. And you can see this is going to solve really well because I can divide both sides by 4, and it gives me my paddling rate at 7. Now, this is a word problem, so don't forget to label your answer. It said that the rates were in kilometers per hour. So I'm gonna label this in kilometers per hour. And that should work right there, right? And we can check up here back in the original equation. 7 minus 2 times 9 is 45. 7 plus 2 times 5 is also 45. So that checks off. The distance is, of course, that means the distance was 45 kilometers, but I suppose that was kind of a different problem, but we were just checking the equation to make sure it was true. An airplane flying with the wind takes 3 hours with a 45 mile per hour tailwind to reach its destination. The return trip takes 6 hours flying against the wind. What is the speed of the airplane in still air? So this one, pretty much the same thing. And I don't know, this one is, if I remember right, does not actually have boxes that you need to fill in, but we do need that original formula, right? We do need to remember that distance equals rate times the time. So we have the two values. We have an airplane flying with the wind. So we have the trip that goes with the wind. And then we have the return trip. I believe that the return trip is against the wind. Okay, now what we know about these two in terms of the distance, because it is the same trip, they would be equivalent to each other. But again, we can't write these in terms of the rate times the time. So that's what I'm going to do. I'll do with the wind in red, and then against the wind in purple. And for those of you that have music playing in your head now that I said against the wind, I get it. But here with our rate, right? So we got with the wind. What did it say? It took. I guess I'm starting with the rate. So we have for the rate, we have the speed of the airplane in still air, but it's adding the tailwind value, which is the 45 miles per hour. Okay, so that's my overall rate here. I'm using R. Maybe I should have used X so it's not confused with the original rate. But yeah, that 45 mile per hour tailwind, that was expressed here in the problem. So when we come back for the return trip, that 45 miles per hour is now against us, okay? So we're gonna take this rate for against the wind. If it'll let me. It's not the most efficient way, but it works. So let's fill in this rate right here. So again, we have the rate of the airplane in still air, but now that 45 is going to work against us. So it'd be minus 45 right there. And then we have the two times as well. So the time with the wind was 3 hours. The time against the wind was 6 hours. So let's get those replaced as well. This is with the wind, and that will be 3 hours. And then against the wind, which is 6 hours. Okay. Well, now we have the equation. This is the equation set up. It's only got one variable, and it's the variable we're trying to solve for. That's the speed of the airplane. So I'll distribute the 3. That's 3R plus 120. Thank you. And then that would equal distributing the 6. 6R. Then 6 times negative 45, that'd be negative 270. All right, so again, just like we saw in that last problem, we're now at the point where we can just solve this equation. So I'm going to use two principles of equality. I got my r's on the left, numbers on the right. So I need to zero out this 135, so I'm subtracting 135 from both sides. But the 6r also is on the wrong side, so I got to zero that out by subtracting 6r there. So now we got negative 3r's on the left. That's 3r's minus 6r's. The 135 zeroes out as planned. 6r minus 6r zeroes out as planned. And negative 270 minus 135 is negative 405. So again, we're at the point where it should be pretty easy to solve here. So let's go ahead and finish solving this for our rate. Yeah, I guess I'll do it in black here. So divide both sides by negative 3. And then the rate here appears to be 135. Yeah, that's positive, by the way. Okay, so that's the speed of the plane in still air. What was the rate? I can see up here is in miles per hour. So I'll just label that 135 miles per hour. That's it. I don't actually use a system to solve this one. What we can do is we got 2 trains leaving, and you can draw a picture if you want to. I don't know. So let's rate it first, okay? A train leaves the station traveling north at 66 kilometers per hour. 2 hours later, an express train leaves the same station on a parallel track traveling north. So that's the same direction at 88 kilometers per hour. How far from the station will the trains meet? And if they're on the same track, they should never meet. or they,
Parallel track.
but yeah, so it should be parallel. But it's like, will they ever meet though? 'Cause parallel lines never meet.
That's true. Yes.
So, but no trick questions, okay? So unfortunately, we will have to assume that they do meet and then solve this problem. So here's what I do for me, okay? So we know, here's what we know, just to start out, okay? So what do they say? A train leaves, we'll say it's the first train. First train leaves at 66 kilometers per hour, and they have a head start of 2 hours. Okay, which also tells us that they have now, because I'm just doing 66 times 2, which is 132. That's 132 kilometer head start lead, I guess. You can word this however you want. But that's kind of the main number that I need right there. It's one of the main numbers I need. I know that the first train leaving, by the time the second train leaves, they are now 132 kilometers ahead. But we know that the second train, excuse me, is faster by, and this is just 88 minus 62. Oh, sorry, I see that's the copying stuff, right? That's 22 kilometers per hour. Okay, so they're going 22 kilometers faster every hour. And what's our question here? How far from the station will they be? With these two pieces of information right here, I can tell how many hours it will take for the two trains to meet. Does that answer the question? No, but it will help me to finalize the question here. So what I'm going to do then is I'm going to take, now I need to write on here, I'm going to take the 132 hours, sorry, kilometers, the 132 kilometer lead, and I'm going to divide this, that's my fraction line, by the speed, which was 22 kilometers per hour. Remember, division is finding out how many of something goes into another thing. And I want to know how many 22s there are in the 132. That would be, that means it's going to take 6 hours for the two trains to meet. But again, it's not asking how many hours it's going to take. It's asking how far from the train station will they be. Well, so I'm going to base this off the second train just because it starts at the train station. It travels for the 6 hours directly, and then it meets the first train, right? So we know that distance equals rate times the time. And for the second train, we know that its rate was 88 kilometers per hour multiplied by the time, which is 6 hours. And we get, so the distance should be 528, but not just by 28, that's kilometers. Now, if we'd done this correctly, we should be able to do this with the first train and get the same value. So the first train was traveling at 66 kilometers per hour. And checking this, and I make this mistake all the time, I would just do times 6, and then we would see that they're not the same. The problem is that the first train not only traveled for the 6 hours, it also had a 2-hour lead. So we actually have to multiply that by 8 total hours. So 66 times 8, enter, and we get 528. So we see that based on this information, they both traveled, I'll use blue, 528 kilometers per hour.